Hi there, my name is Lindsay Sample, and today I'm going to be talking to you about IBM's data fabric on Cloud Pak for Data and how it can help universities and schools. I wanted to start out today with a persona-based story to illustrate what we're seeing with a lot of universities in the current state and the future state that we are helping to create for them. So this is Dylan. She is the Dean of Students at a large university. She serves as a liaison between students and administrators, assesses student body needs and responds to concerns from the student body, and she provides proactive leadership and structure to ensure school development and conducts consistent department evaluations to determine how efficient they are running, and if necessary, recommends ideas for improvement along with annual statistical reports. Right now, data at Dillon's University is siloed. So the admissions office may have some data, the financial office may have data, there's data from the learning management system, the career development office, and so on. And this data can come in from many different infrastructures in many different formats and from many different locations across campus, or even spanning multiple campuses around the US or even the world. Right now, Dylan doesn't have access to all of this data to make sense of it or draw any meaningful insights from it that could help benefit her students and her university. She has no idea what data she has, let alone how to use it to help improve student outcomes for use cases such as identifying patterns in student retention, optimizing class schedules, or comparing her university to other similar schools that compete when it comes time for admissions. Now imagine a future state for Dylan with an intelligent data fabric that allows her to connect to these disparate data sources wherever they reside and bring them all together in one platform so that it's easy to access and to use to collaborate with. Now, Dylan can systematically make sure her data is organized and appropriately governed, that sensitive student information like social security numbers are protected, and she can even clean and transform her data in a format that allows her to uncover those patterns and insights that we were talking about earlier to help with student success and university planning and understanding a more holistic view of her students. This makes everyone at the university happy because obviously we can make the best decisions we can when they are informed by data. We hope that this story resonates with you and the challenges that you may be facing at your university. If that is the case, we'd love to show you how Cloud Pak for Data can take your university into this future state and help establish a data fabric that will enable you to make the best decisions for your students. So why is this so challenging for universities and schools? Well, they're prevented from delivering on these initiatives because they have a lack of a view into their data sources, types, and domains. And ultimately, this renders them ineffective at seeing the whole picture for their students and being able to drive the outcomes that would really benefit them. They're prevented from seeing the whole picture because they've built up architectures of best point products for years and even decades. And this leaves them with an architecture that's difficult to maintain, hard to use, and ultimately not used by the personas that would benefit most from their data. And this complexity leads to 60 to 73% of their data going unused, which is a shame. One analogy that I like to use for these kind of point products and architectures that have been built up over years is that of, we used to have a GPS and a CD player and a phone and a camera. And now, we know that all of these things are together on one platform like a smartphone. So that's the idea behind Cloud Pak for Data. This is the platform in which we deliver our data fabric. Today in our demo, I'm going to be taking you through Dylan's journey of connecting to her data, making sure that sensitive information is protected, and even creating a model so that she's able to identify which students are at risk of dropping out based on her historic data. So let's jump into it. Here we have our Cloud Pak for Data homepage. Now, with such a robust platform to support everything that we would need to create a data fabric, there's lots that we can do here. So here we have our navigation panel, which will always be on the side to help us navigate. And let's go ahead and get started with data virtualization. Here's where we're able to see all of that data that we're able to connect to in the platform. So for example, we have some DB2s, some Microsoft SQL Server, some Oracle databases, and we can see the health of each of those databases at a glance too. Here we can see all of the data sources that are already built into the platform, so it's very easy to add new ones. Now, once we've connected to our data, I can come shop for data in my catalogs. I can see what's available to me based on my user persona, and access can be controlled at both the catalog level, if I'd like everyone in the catalog to be able to look at the assets, or at the asset level itself. So maybe I just want to add people specifically to an asset. and it's up to my organization as to how I would like to organize my catalogs. So let's dive into this data set. This is called student person. If I come to overview, I can see that someone's left a review. They've given it 5 stars. This is great, lets me know that it's a good asset and that I can collaborate with other folks. I see that there are also some tags, so I can tag them if that was a way that I'd like to organize my data. I can see that the social security number of these students has been masked because I don't have access to see it, because that's not something I need to know if we want to make sure to comply with regulations and protect student information that needs to be protected. Here, I can decide if I'd like the whole catalog to be able to see the asset or to add members specifically. I can write a review as we've seen before and take a quick look at the profile of the data. So I can see, are there many missing values here and what am I working with? And then I can go ahead and add it to a project if I'd like to get going on some analytics here. Now that I'm in my project, there are several things I can do in a project. I can add in data from the catalog and pull it in this way if I'd rather. I can create a notebook if I'm an experienced data scientist where I can work in R or Python. I can create a modeler flow where I can schedule jobs and use a graphic interface if I'm not necessarily an experienced programmer, but I know a bit more than the average Joe, and I would like a guided method of doing my machine learning and my data processing. I can create a dashboard so I can visualize data and communicate with stakeholders. I can create a data refinery flow if I would like a graphic user interface to do some transformations to get my data ready for modeling. But today, what I'd like to do is to show you what we call an auto AI experiment. This is a way that we can create models if we're not an experienced data scientist, and maybe we're just a business user who wants to quickly get some insights and understand what's going on with our student data. This is a tool that can also be used by experienced data scientists to give them a starting point with some algorithms that might be of interest to them that they can then tweak and expand upon later. We're going to be working with the data set that I've created called student training data. This is going to tell us some information like the age of students, their socioeconomic status, their GPA, how many clubs they're in, how many AP courses they took before arriving at college, what year they are, just some things to show us the art of the possible about what we might learn about students and what might influence them to drop out. So here we've seen from this historic student data, there are some students who have dropped out and some who have not. And what we want to do is identify some patterns in this so that maybe in the future we can predict which students are likely to drop out before they do and provide some preventative action. So I'm going to create a new auto AI experiment. I'll call this student dropout prediction. Next, I'll select my data source and choose that I would like to predict are students going to drop out. Auto AI correctly identifies this as a binary classification, a true or a false, but this could also work with a multi-class classification as a high, medium, or low risk, or a regression if we have continuous data. Here I can decide how much data to save out for training and testing, and here I can decide if there's any columns that I'd like to exclude. We can see that Auto AI is going to optimize for accuracy, which works for us, and that it's going to test 7 different algorithms. So this is a really great feature that I think provides an advantage or a differentiator where you're able to test all of these different algorithms, and that can give your data scientists a really good starting point so that they don't have to waste their time either using an algorithm that they always use or not knowing where to start. So now we can run the experiment. This will take a few minutes to run since we have lots of data, but we can see what it looks like when it's all done. So here's what our model looks like when it's all done. We can see that it's chosen the 2 best algorithms. So let's click on the best performer and explore. Here we can see all of the typical information we'd expect for our model evaluation. Here we can find our confusion matrix that tells us information about our true negatives or our false positives, and we can evaluate how our model is doing. But my favorite part is the feature importance. So this is where we really start to dive into getting the insights and understanding our data. So this tells us that the most important features when trying to predict student success and student risk of dropping out were absences and GPA. So that might tell us a little bit more about what to dive into with our students and maybe even give us some ideas about what information we might want to include in the future. Like for example, we can see that clubs is actually a factor here as well. So who would have thought that maybe how many clubs a student is involved in might be a predictor or an influencing factor on whether or not they drop out. And this can also give us a starting point as to where to dive into to try and understand that more, right? So how can we dive into our data to understand, is it the case like we would expect that the number of clubs students are in, if they're in more clubs, they're less likely to drop out? Or is that actually not the case? Maybe students are getting overwhelmed with too many clubs. So this gives us a great starting point to dive into our data and understand further what's going on. Then we can save our model either as a model in our project, which we can then deploy to a deployment space, or as a notebook so that we can dive in, edit it more, and it's not just a black box, but can provide a starting place for us to tweak and to dive into further. Once we've saved our model, we can promote it to a deployment space. We can deploy it online or in batch if we'd like to run it against several students at once. And as you can see, within just a few moments, our model is deployed, and we're able to start running new students against it to see which students are at risk of dropping out so that we can intervene and really make an impact before it's too late. So say we have an 18-year-old female student. Her GPA is a 3.0. She is in 3 clubs. In high school, she took 5 AP courses. She is a freshman, and she has 10 absences. We can see how likely she is to drop out. She has a 96.7% likelihood of not dropping out. So that's great for this student. And if we'd like to test many students at once, we can do that as batch. We can use dashboards to get a general overview of our student body, or to use that batch scoring to get an idea of which students are at risk so we can send alerts to academic advisors. And we can also use dashboards to maybe look at how our school is doing compared to other institutions and answer some research questions we may have related to our university strategy. So, for example, looking at enrollment at some of the other schools across the US, or perhaps tuition costs as we're making decisions. Today we saw how Dylan was able to connect to her data that resided in different places, how she was able to bring it together into one platform where she could protect her students' sensitive information like social security numbers and collaborate with other users using catalogs, and how she was able to use this data to draw insights from it without even needing to know how to code so that she could identify students at risk of dropping out and take action before it was too late. Then she could visualize this data to better understand what was going on with her students and her university as a whole. I hope you enjoyed this demo of IBM's Data Fabric on Cloud Pak for Data. Please feel free to reach out if you have any questions or would like to learn more. Thanks so much for your time.